The logarithmic function is the inverse of exponential function. Now, to be able to solve for the limits at infinity and infinite limits of logarithmic functions, we need to understand the two cases. First, when the base a is less than 1, is greater than 0 but less than 1, and when the base a is greater than 1. So we need to understand first how does the graph of logarithmic function behave with these two possible cases. Now, the very popular example for logarithmic function is the base 2 logarithm y is equal to logarithm of x base 2. And by definition of inverse function, the range of y that is equal to 2 raised to x, which is 0 or all real numbers greater than 0, becomes the domain of y equals logarithm of x to the base 2. Well, the range becomes the domain of its inverse, or vice versa. Now remember also that in the logarithmic function defined by f of x is equal to logarithm of x base a, x here is a set of input values from the interval 0 to positive infinity, or simply all positive real numbers. It means therefore that from the logarithm of x base a, we do not this x here does not accept all values which are negative, and so with 0 there is no such thing as logarithm of 0 and logarithm of a negative number. Now, we need to focus on the domain and range of the logarithmic functions in order to understand the limits at infinity and infinite limits of this function. Tingnan natin ngayon ang graph ng f of x is equal to logarithm of x base 2. This is the graph of the logarithm of x to the base 2. And as we can see here, x here, the domain x is a set of all real numbers which are positive. That is why when x here keeps on approaching 0 from the right, as you can see, this is x that is equal to 0, the vertical asymptote, and it does not allow the graph to pass through it. However, x can just keep on moving closer to that 0. And when we observe the behavior of y as x keeps on approaching 0 from the right, y here keeps on decreasing. However, if you observe the increasing values of x, y also increases infinitely. Therefore, we can have the two possible properties from the graph of the basic logarithm of x base 2, or a very popular example of logarithm. We have the first logarithm of x to the base 2 as x approaches positive infinity is positive infinity. And the logarithm of x to the base 2 as x approaches 0 from the right is negative infinity. And that is also proven in the graph. By graphical analysis, we can see the infinite limits and limit at infinity being illustrated. With that, we can say that the general rule in understanding the limits of logarithmic function in the limits at infinity and infinite limits, let's say for example that a here is any real number greater than 1 and u is any function. Therefore, we can say that the logarithm of u to the base a as u gets closer to 0 from the right is negative infinity. However, when the logarithm of u to the base a, getting the limit of that as u keeps on increasing without bound is also positive infinity. Again, u is a function, so u can take any possible expressions just like x plus 1, x minus 1, okay? Because u is just a representation of that kind of function. To understand that, let's have number 1 problem. Logarithm of x to the base 3 as x approaches 0 from the right is negative infinity. Well, basically, that is being suggested by the rule also that when this x here becomes 0 when x is 0, right? However, it cannot take all values from the left of 0 because that is not allowed. There is no such thing as logarithm of a negative number. Meaning to say, it is only limited to all values of x very close to 0 from the right. And when you observe the reaction of y keeps on decreasing without bound. So here is the graph of that. As x gets closer to 0 from the right, y keeps on decreasing. However, if you observe, if we keep on increasing the values of x, no, keep on increasing that, y will keep on increasing also. So the behavior of the graph is already seen on the given illustration. The third example, logarithm of x minus 1 to the base 3 as x gets closer to 1 from the right. Why is it that it becomes infinite? If you're going to get x minus 1 here and equate it to 0, it is 1 that makes it 0. So 1 minus 1 is 0. However, since 1 makes it 0, then all numbers greater than 1 will make x minus 1 positive. Or in the other hand, we can also say since that number x minus 1 should not be less than 0, so we can have here that is greater than 0, so meaning to say all values of x greater than 0 are allowed. That is why when you are asked to get the limit as x approaches 1 from the right, then we can just say it's negative infinity. You see here that x approaches 1 from the right and y keeps on decreasing without bound, making it negative infinity. But in the fourth example, if we're going to observe naman the infinite limit, the limits at infinity, if we keep on increasing values of x, what will happen to logarithm of x minus 1 to the base 3? Look into the graph here. X keeps on increasing, y does the same. Okay, so that's it. And this x that is equal to 1, the value of x that will make the number 0 will become equated to x will become the vertical asymptote. Fifth example, okay, 2 minus x. If you get 2 minus x and equate it to 0, so negative x is equal to negative 2. When x is equal to 2, then 2 minus x becomes 0. If you're going to get the values of 2, okay, observe left of 2 and right of 2. On the left of 2, as you can see here, this one is negative x. So meaning to say, to make the values of 2 minus x positive, kailangan mong magkaroon ng values ng x na negative or decreasing. Bakit? Because negative multiply to negative make it to positive. Hindi mo pwedeng gawing i-increase mo ang values ng x kasi pag inalakihan mo ang values of x na to, for example, ginawa mong 3, so 2 minus 3 becomes negative 1, which is wrong because there is no logarithm of negative 1. Does not allow. That is why when we observe the graph of this function, we can vividly see that when x keeps on approaching 2 from the left, then y keeps on decreasing. That is the reason why this is negative infinity. It is by inspection, class. If you try to inspect this, now, when you keep on approaching 2 from the left, bababa at bababa ang values nito. The logarithm of 2 minus x to the base 5. It keeps on decreasing. Okay? Kaya yan negative infinity. However, paano naman kapag ang ginawa mo is in-increase mo ang dinicrease mo? Okay. Why is it that there is no such thing as x approaches positive infinity in this kind of problem? Because take note, class, x approaching positive infinity would mean all numbers that are positive. So let's say, for example, if you have 4, if you have 5 as values of x which are positive, then that should not happen. No. It does not allow because 2 minus 4 is negative 2. There's no logarithm of negative 2. So when you're asked to get the limit as x approaches positive infinity, you can simply say it does not exist. The graph also tells you that there is no graph on the right of 2, meaning to say really the graph does not behave on that part, or there is no behavior on the right side. That is why in number 6 problem, you are just asked to get the limit of logarithm of 2 minus x to the base 5 as x approaches negative infinity. The answer is positive infinity. Why is it, class? Because if you have 2 minus x and all values of x are negative or decreasing, like you can have negative 3, negative 4, negative 5. When you're going to subtract that from 2, then you will have this, right? Just to give you a trend para mapansin mo by inspection kung ano nangyayari. So ito magiging 5, this becomes 6, and this is 7. So when you're going to get the logarithm of 5, logarithm of 6, logarithm of 7, all values becomes increasing. The values increase. No? That is the reason why this is positive infinity. The graph can also prove to you that when you keep on decreasing the values of x, as you can see, it's decreasing. Paakyat naman ang values ng y. Y keeps on increasing. So, bumaliktad siya. Has to compare with the third problem. Now, to add other examples, let's say if you have the logarithm of 5 minus x, okay, let's say this is to the base 7, then you're going to get the limit of that as x approaches, let's say, negative infinity. And by inspection, class, if you're going to say negative infinity, you are referring to negative values of x. So since this one is subtraction, when you subtract a negative number, then you expect that will be positive. So when you keep on adding 5 to all positive numbers, because on the final sign this will become positive, then all numbers becomes positive, meaning to say all values of y keep on increasing. Pero kung papansinin natin ang pagkakaiba niya naman, kung papansinin natin naman ito, paano kung ginawa nating logarithm of x minus 5 as x approaches negative infinity? Pwede kayang gumamit ng negative infinity? If we try to inspect, class, ito kasi negative infinity and this is positive. So meaning to say all decreasing values. So paano kung gumamit ka ng negative 2? Pwede ba? Hindi pwede, no? Because you are just limited to all values greater than 5. And this one are negative values, hindi pwedeng gamitin. So this is DN. However, if you take a look into 5 minus x here, itong si 5 minus x kasi ang kanyang domain is a set of all real numbers, less than 5. Bakit kaya less than 5? Una sa lahat, because when you're going to, that must be less than 5. Because 5 minus 5 is 0. Okay? And then if you're going to get, because this should not be a negative number, right? So you have negative x is greater than 5. Negative x is greater than negative 5. So when you're going to divide both sides by negative 1, from greater than na symbol, magpapalit yan into less than negative, less than positive 5. So just remember your inequality in general mathematics. Kaya in interval notation, yan na siya. So sa madaling salita class, hindi ka pwede magkaroon ng values na increasing. Okay? You should not have values which are increasing from the given. So in number 7, let's say for example, nagdagan natin yan, limit of logarithm of 5 minus x to the base 7 as x keeps on increasing. Is this allowed? No. This is DNA. Because you violated the rule of domain that the numbers will just be decreasing, no increasing values of x. And since 5 will make this number 0, 5 minus x will become 0 when x is equal to 5. We can also say that when you're going to get the limit of the logarithm of 5 minus x as x approaches 7, to the base 7, that must be base 7. So x keeps on approaching 5. Is it right or left? Tandaan mo, right of 5 ay hindi pwedeng gamitin dahil yun ang sinasabi ng domain. Ibig sabihin, left of 5 lang. And your answer here is negative infinity. So, ang tama dito sa number 8, DNE yung negative infinity. Ang ginagawa ng x na decreasing, hindi pwede kasi sabi ng domain, lahat ng numbers na nag-i-increase. No numbers that are decreasing. So, if you're going to get the logarithm of x minus 5 to the base 7, as x keeps on increasing, then your answer is positive infinity. However, if you're going to get the limit of the logarithm of x minus 5 to the base 7 as x keeps on approaching 5 from the right, your answer is negative infinity. So why is it I place here right of 5? Because the domain tells you that all numbers allowed are just from the right of 5. Hindi mo pwedeng sabihin left of 5. Dahil kapag left of 5, then D and E na yun. So after talking about the base that is greater than 1, now let's talk about the base which is greater than 0 but less than 1. And again, we have these possibilities or the properties. To appreciate these properties, tignan natin yung graph nito in number 1. 1/5 is the base, so meaning to say, pasok siya sa a number that's greater than 0 but less than 1. Kung papansinin mo yung graph ng lahat ng base which is between 0 and 1, kapag dinidecrease mo, when you keep on approaching number 0 from the right, ginagawa ng y, nag-i-increase. Yun yung sinasabi nitong first rule. When the logarithm of u to the base a, where u is any function and a is a number between 0 and 1, and you keep on approaching 0 from the right, that's positive infinity. However, kapag in-increase mo ng in-increase daw ang values ng x, ang gagawin ng y keeps on decreasing. So yun yung sinasabi ng rule. Okay? Now, as your guide, you should always observe the base. So itong dalawang ito, dahil alam natin na ang x magiging 0 when x is 0, definitely. At hindi ka pwedeng magkaroon ng negative values, no? So kaya nga, limited ka lang sa right of 0. Kaya ito yung sinasabi nito. Right of 0, and that will give you positive infinity. Okay, number 3, nakikita natin ang base that is 1/9, and this is positive infinity. We also know that x minus 4 will become 0 when x is equal to 4, right? So you can just only use all numbers from the right of 4. So ito yung sinasabi na niya, right of 4. However, kapag tinuloy-tuloy mong i-increase ang values of x with a base that is less than 1 but greater than 0, ang ginagawa ng values ng y keep on decreasing. Kita naman natin sa graph, pababa na siya. Okay? Pero kapag nilalapitan mo ang 4 from the right and the base is simply 1/9, which is less than 1, y values keeps on increasing. The graph shows you that. y values keep on increasing. On the fifth example, the base is 3 over 7 and 3 over 7 is simply less than 1. Okay? At itong 5 minus x becomes 0 when x is equal to 5. Diba? So ano yung, dahil negative x ito, ibig sabihin right of 5 ang kailangan mo. Kaya nandito sa number 6, right of 5 lang ang pinakita. But why? Because the tendency class, kapag right, pag right of 5 ang ginamit mo, nagiging negative lahat ng values. Clue, you have 5 minus 6, this is already negative 1. Because right of 5 are numbers greater than 5. It should not be very close to 5. Siyempre, a number very close to 5, let's say 5, 0, 0, 0. Imagine mo, this is already negative 0.0001, which should not be the number involved in the logarithm. Kaya nga, left of 5 lang ito. So, going back to number 5, when you get the logarithm of 5 minus x as to the base 3 over 7, okay, as x keeps on decreasing, then it becomes decreasing yung values ng ang ginagawa ng y. Bakit? Okay? Bakit ganun na nangyari? Because when you keep on having values of x which are all negative, kasi yung negative infinity, yan sabi niya. Bababa at bababa. Take note, okay? Take note na ang sinasabi natin dito is 5 minus x. That will become always positive, no? Always positive when you keep on having values of x which are less than or negative values. Gagawin ng y niyan, y will keep on decreasing. So halos katulad din siya ng sinasabi niya sa number 3, no? Na kapag magkaroon ka a logarithm of a number that keeps on increasing, samantalang ang base mo is less than 1, ang tendency is pababa ang values ng x. Values ng y. Okay? That is also in here, as we can see, ang nangyayari is logarithm and then yung x yan keeps on increasing with the base of 1/5. Ang mangyayari is pababa infinitely ang values ng y, as you can see. So it matters to observe how does x or the number here behave, no? With regards to the behavior also of the abscissa. Okay, but in here, in number 6, as x approaches 5 from the left, at bakit 5 from the left ang kailangan natin? Kasi nga, this is minus x, so ibig sabihin, we need a negative number to have positive sum or product. Okay, then 5 added to a positive will definitely be positive. So when you keep on approaching 5 from the left, aakyat ang values ng y, making it positive infinity. So let's have another example. Let's say if you have logarithm that is base 5 over 9, obviously less than 1, and this is let's say 3 minus x. What is the limit of that as x approaches 3 from the left, no? And let's have number 8. What is the limit of the logarithm of 5 over 9? A logarithm of 3 minus x, the base 5 over 9, as x approaches, let's say, as x keeps on decreasing. Okay. So, dito sa number 7, when you keep on approaching 3 from the left, no? Left of 3, keep on approaching that. Ibig sabihin nito, yung 3 minus x na ito, ang gagawin ng 3 minus x, tuloy-tuloy siya sa pag-increase. No? That is also being supported. Katulad lang din siya ng number 5. Na kapag lalapit-lapitan mo ang 5 from the left, they're always the same, right? 3 minus x lang yung given dito. Okay? They also have the same behavior on the base, which is less than 1. Then, ang mangyayari sa values ng 5 minus x ay tuloy-tuloy sa pag-increase. Okay, and here, logarithm of 3 minus x to the base 5 minus 9 over 9 as x keeps on decreasing. Kung mapapansin natin si 3 minus x, 3 minus negative infinity in the behavior of x will give you 3 plus positive infinity, which is positive infinity. So when a number keeps on increasing, but it has a base, when the logarithm of a number that keeps on increasing, but the base is less than 1, the tendency here is the entire logarithm, no? The entire logarithm will keep on decreasing. Kabaliktaran siya kapag meron ka namang base na, kung nagkaroon ka ng base which is, let's say, 3, which is greater than 1, ang tendency, ang corresponding niya is positive infinity din. Kabaliktaran niya yung less than 1 naman na base. You see the difference? This is 3, this is 5 over 9. Pareho silang positive infinity na nag-increase sa number. Magbabaliktad ang kanilang magiging behavior for y. This is positive infinity, the other is negative infinity. Because it also that is also being proven, class, by the negative integral exponent. No, it is also being proven. If you have 1/2, you raise it to -2. This will become this becomes 4. Isn't it? Because if you have 1/2, then ilagay mo yung -1 sa loob, then this is 2. This will become 1/2 the quantity raised to -1 is 2. So 2 raised to 2 is 4. So ibig sabihin nito, class, ang lahat ng numbers na decreasing, mag-i-increase ang values, no, ng logarithm kung ang exponent mo ay tuloy-tuloy sa pag-decrease. So I think with this you can understand. Itong -2 pa lang yan. Paano kung liitan mo pa siya, gawin mong -3, tapos ang base mo 1/2? What would you expect? This becomes 8. So nakikita natin na lumalaki yung kanyang corresponding value. So alam natin na ang logarithm talks about exponent. Kaya nga negative infinity ang ginagawa ng y bilang isang exponent. Dahil kapag pag nililiitan mo pala ang values ng exponent, -2 is greater than -3. So nililiitan mo siya. Yun yung sinasabi ng negative infinity. Ang magiging value ng buong exponential na yan ay tuloy-tuloy sa pag-increase. Ito na yung sinasabi ng logarithm of positive number. Okay? So ganun lang din ang definition niya, class. Kaya ganun ang nangyayari, no? On that kind of case under less than 1 but greater than 0.